So far, we have considered the case of negative externalities, and in particular the case of public bads. Now we're going to look at the reverse case, which is the case of positive externalities, and in particular at something called public goods. Now public goods are going to be positive externalities, an instance in which there are positive externalities to other consumers or firms, or both. And there is what is called non-rivalry in consumption. And what this basically means is that every actor can benefit from the positive externality. Let me give you an idea to define that more carefully. For example, a typical externality, positive externality, is basic R&D. If a company invests in R&D and comes up with a new idea that other firms can use, every firm, every consumer in the economy can use it, and the usage of one person doesn't diminish the fact that it can benefit others. In that case, it's non-rivalry in consumption. In contrasting what happens when somebody produces an apple, if somebody eats it, consumes it, nobody else can. So public goods have this feature of positive externalities and non-rivalry in consumption. What are other examples? Very famous example that I like a lot, if in the United States, is something called the LoJack anti-theft system. So in the United States, they sell this system that you can install in your car that basically is like a beeper, a locator for cars. And if your car gets stolen, it allows the police to track the car to the thieves. Now this is very useful because it turns out that thieves steal many cars and they bring them to a common place. And therefore, when through the LoJack they locate your car, they actually arrest the entire band of thieves, and that decreases the probability that everybody gets the car stolen. That is a direct positive externality that looks like a public good. Another one that we have mentioned before is what I call network externalities in consumption. For example, HBO or Facebook. These are activities that your marginal benefit from consuming may increase on how many other people are consuming or engaging in them. So, as before, there are many different detailed models of public goods that depend on the specifics of the problem, and here we're going to talk about a general one that captures the essence, and it's a very simple one. So the idea is that there are end consumers, each of whom has a utility for Q, M, and the externality given by B of Q plus M plus gamma G of the externality. And now G is greater than 0, G prima, and G double prima is less or equal than 0. This is a parameter greater or equal than 0, measuring strength of the externality of the public good. And as before, we're going to assume that E is just the sum of the Q's, to keep it simple. The other aspect of the model is that Q is produced at constant marginal cost mu. So it's a very, very simple model that parallels the one that we saw for public bads, but now the externalities are positive. What does the equilibrium and the deadweight loss look like in this case? Let's think about it. We have dollars per unit. We have Q. We have mu equals to the marginal private benefit, the marginal private cost and the marginal social cost of production. And we have this curve, which is going to be the demand function in the market that the individuals have, which is the marginal private benefit. But we also have this other curve, which is going to be the marginal social benefit, and this gap is going to be given by gamma and G prima. Okay. In this case, the marginal social benefit is above the marginal private benefit because there is a positive externality. What do we have? The market is where marginal private benefit is equal to marginal private cost, so it generates this quantity but the optimal quantities where the marginal social benefit and marginal social cost intersect, which is this. So there is underproduction. We derive this graphically for this very specific model, but as before, this is a very robust result for public goods. What's the deadweight loss in this case is going to be this triangle for analogous reasons to everything that we have been seeing. Now, it shouldn't be surprising to you that the opposite case of Pigouvian taxes can be used as a corrective policy for the case of public goods. With public goods, there is a problem of under-provision, so we have to subsidize instead of tax the behavior that is not being supplied sufficiently to encourage it. So what is the policy here? You're going to subsidize the sale or consumption or purchase, depending on whether you put it in the consumer or in the firm, of good Q with a subsidy sigma star equals to the marginal externality social at the optimum. And it's going to be financed, the cost of the subsidy is going to be financed with lump sum taxes. And the result is that this policy, Pigouvian policy, restores efficiency, just as before. Now, in some cases, another good corrective policy is government provision. Look at an example or an extreme case in which the utility function of the consumers has 0 plus m plus gamma g of e. So in other words, there is no direct, no consumption benefit of qi, but there is a positive externality. In this particular case, we're going to have that the Q of the market is equal to 0. Nobody's going to provide anything. And we're going to have that the optimal policy, the government can restore optimality let me say it differently. The policy first buy a Q optimal and finance with lump sum taxes restores optimality. This is basically a case in which the government just goes directly and purchases the optimal amount. And as before, as we have been emphasizing, notice that this requires extra information on the part of the government. One remark is that policy not optimal if lump sum taxes are not possible. In other words, if the government needs to finance its purchases with a tax that creates a deadweight loss, it's never going to be able to restore the first best, because every time it raises revenue, it creates an inefficiency. And the benefit from the public good and the cost of taxation needs to be balanced in that case.